Welcome to the video on 2.04 where we're going to look at empirical formulae. So the definition of empirical formulae is the simplest whole number ratio of atoms of each element in a compound. So the best way to look at this is to do some examples. So the simplest sort of question you're going to get is to actually write the empirical formula. Now this doesn't come up very often, but you might be asked to do it. So we'll just go over it. So don't worry, because you haven't learned the organic chemistry for this. So I'm just going to show you the process. So don't worry about the fact that you don't know what 4-hydroxypentene is. But if I draw this out, pentene is 5. So 1, 2, 3, 4, 5. Pentene would be a double bond there. And 1, 2, 3, 4. Hydroxy means I've got that. So again, don't worry that you can't draw this out yet. You'll be able to do it once you've done the relevant organic chemistry bit of this. So if I just add all of these in, so that each carbon's got 4 bonds. Right, so once you've drawn the molecule out, then you just need to accumulate all the number of the different elements. So there are 5 carbons there, and if I add the hydrogens up, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I've got 1 oxygen. So that's my molecular formula. And then to get the empirical formula, it's the simplest whole number ratio. So I divide by the highest common factor. Now in this case, the highest common factor is 1. So the molecular formula is the same as the empirical formula. So the answer to this is B. But if it came out as something like C3H, that's not going to work. So if it came out as something like C4H8O2, then the highest common factor there is 2, so I'd divide everything by 2, so it becomes C2H4O. So the most difficult question you're going to get is to work out the empirical formula given mass data. So analysis, this is an exam question where it's asking you to interpret the analysis of a hydrocarbon. So a hydrocarbon is just hydrogen and carbon. And it says it contains 83.7% by mass of carbon, and it wants us to calculate the empirical formula. So it gives us the ratio by mass. We need to turn this into a ratio by number of moles. So I just write down my 2 elements that we're interested in. And the first thing I do is write a percentage down. Now, sometimes I'll give it you in grams, sometimes I'll give you a percentage. It doesn't matter. You can just use the same data. So carbon is 83.7 and hydrogen is 100 minus 83.7 because it's got to add up to 100% and it says it only contains hydrogen and carbon. So 100 minus 83.7 is 16.3. So now I can need to convert it into the number of moles, and the number of moles is mass over the relative atomic mass. So 83.7, so for carbon that's going to be 83.7 divided by the atomic mass of carbon, which is 12, and for hydrogen that's going to be 16.3 divided by the atomic mass of hydrogen, which is 1. So that's going to give me the 2 numbers, 16.3. If I stick that into my calculator, it's going to give me 6.975. So now I need to get the simplest ratio of these 2 numbers. So the quickest way to do it is divide by the smallest number. And if I do that, so that becomes 6.975. So one of them will become 1. So that will become 1 because that's the smallest number. And 16.3 divided by 6.975 gives me 2.33. Now we can do some rounding to the nearest whole number, but if it comes out as about 0.5, then you would times everything by 2. And if it comes out to about 0.33, because that's a third, you would times everything by 3. So in this, that would give me 3 for that one, and 3 times 2.3 is 7. And that would then give me an empirical formula of C3H7. So the last step is it wants me to calculate the molecular formula. So it tells me the molecular mass. So if I work out the mass of this unit here, That's 3 times 12 plus 7 is 43. So if I divide the molecular mass by the mass of my empirical unit, that gives me 2. So what that means is I've got 2 of these empirical formula units in my formula. So I just need to times C3H7 by 2, and that will give me the molecular formula. So that will be C6H14. So my molecular formula is C6H14. So the other sort of question they can give you is where they give you water of crystallization. So this is in essence the same process, it's just we need an extra step. So in this reaction, I've got nickel sulfate with some water in, and I don't know how many of those waters I've got. And when I heat that, I'm going to get my nickel sulfate and I'm going to get X moles of water. So what I'm trying to find out is this X. I'm trying to find out what that ratio of water to nickel sulfate is. So it tells me that I start with a mass of 2.287 and that I end up, once I've heated it, so the water's driven off as steam, and I end up with 1.344 grams of nickel sulfate. So if I do my maths here, so the amount of water is going to be 2.287 minus 1.344. And if I stick that into my calculator, that's going to give me 0.943. So what I've got is 1.344 grams of nickel sulfate and 0.943 grams of water. And now we can just do the same thing we did on the previous slide. So that's my mass. So I'm just going to come over to the left-hand side here. So I'll write these out again because my board's getting a bit messy. So I've got my nickel sulfate and I've got my water. And I know I've got 1.344 of that and I've got 0.943 grams of that. So that's my mass. So I need to turn my mass into moles. So the number of moles is the mass over the MR. So in this case it's MR rather than AR because we're not talking about elements. And if I add these up, so nickel, if I look in the periodic table, is 58.7. That's 58.7. Sulfate is 32.1, and oxygen, there's 4 of them, and there's 16 each. So if I add that up, that gives me 154.8. So I'm going to divide 1.344 by 154.8, and if I stick that into my calculator, it gives me 0.00868. If I do the same for here, I'm just going to shift a little bit to the right because I've run out of space a bit, so 0.934. So hopefully you know the MR of water already, but just in case, that's 2 lots of 1 and 16, which is 18, so I divide that by 18. When I stick that into my calculator, I get 0.057. Right, so now I divide that by the smallest number, so the smallest number is that. So now I'm dividing by the smallest number. That's going to be my 0.0573 divided by 0.00868, and when I stick that into my calculator, it gives me 6.